concepts, and here's my thinking. If we focus first on logical equivalence, we can not only review stuff that we've covered, but I hope also clarify a question that Cody had raised in connection with one of the exercises that involved translation. Okay, so the ordinary language sentence, if memory serves, and I'm going to actually just type it in the sentence pane, was neither, was it?
Neither D nor C.
Thank you, Cody. Neither D nor C
is in front of either C or B.
Okay, so we've got a couple of items to deal with here. One is a translation item, and then the other is whether or not two different translations are equivalent to each other. Okay, so, and by equivalent, we're talking about whether or not there is a world in which one of the translations is true while the other is false. And if that's the case, then the two sentences aren't logically equivalent, right? So we'll talk a little bit more about logical equivalence, but this is where we were. And if memory serves, we ended up with the following. So we had a negation in front of an open parenthesis, and then we had D front of C. Oops, I'm mistyping. Hold on. And sorry again for those of you I'm standing right in front of. I'm going to move out of the way as quickly as I can. D front of disjunction, front of D, B, disjunction, front of C, C, disjunction, front of D, B. Have I covered everything? Am I missing anything? And for those of you who need to have, who need to actually see this, there, I made it a little bit larger, right? Forgive me, I don't recall if this was exactly what we had. I think actually we had a sub-parenthetical, right?
Yeah, we had an incorrect translation because it didn't work when I submitted it.
When you submitted it, you were told, hey, there's a problem here. So one of the things we want to do is to understand what it is about the translation that didn't work. But for the moment, is it fair enough to say that we have a series of disjunctions and then we have a negation in front of the whole thing, right? So we're basically getting a series of, it's not either this one or this one or this one or this one, right? And we know that if we're saying it's not either this one or this one or this one, we're rejecting each of the disjunctions, we can, we feel mentally, especially given what we know about De Morgan's equivalences, as if, and I'm just going to, for the sake of time, copy paste, at least I hope this is going to help for the sake of time. We know that when we have a negation in front of disjunction, that negation can be pushed through, and each of the disjunctions becomes a conjunction. Yeah, Mihai's exactly right. So conjunction, conjunction, okay? right? How are we doing with this? So far, so good. So part of Cody's issue was the original translation, not the one that you see at number 2, right? But the original translation was problematic. He understood it was problematic if for no other reason than when he submitted the file, Grade Grinder says, oh, no, right? But when he submitted the file with the number 3 as the translation, everything worked out just fine. So what was the offending translation? Well, let me add one more row here. And again, I'm going to try to do or actually I don't need to copy paste because we've already copied it. I can paste it. If memory serves, we had the following, namely, a negation in front of a disjunction, and then within the sub-parentheses, 2 conjunctions, right? So there's no issue with the negation in front of a parenthetical with the disjunction as the main connective, right? It is a neither nor sentence. The driver, if you will, is the negation. What is the negation rejecting? It's rejecting an or. It's rejecting an either or. So not parentheses or is not either or neither. The question between 3 and 4 is, which is the correct, if you will, sub-connective? Is it a series of conjunctions, as you have at 3, or is with a negation in front of each of the atomic sentences, or is it the case that you have conjunctions and parentheticals? One way you can tell whether or not the sentences are equivalent, namely whether or not 3 and 4 are equivalent, is to construct a truth table. So that brings us back to one of our initial concepts, which is sentences that are equivalent to each other. The broader concept, logical equivalence, is a concept that involves sentences going back to, I think it was, maybe now I've confused the exercises, but like 3.9, right, where you're supposed to write a sentence that's equivalent to the original but use a different predicate. So for example, the sentence smaller AB is logically equivalent to the sentence larger BA, right? They say the same thing, and you can see that in Tarski's world, but if you, and we'll see this in a truth table, but if you throw the sentences in a truth table, you'll see that you don't get the same equivalence. And that's because the truth table is, if you will, a machine designed to churn out possible truth values that are functions of connectives and the sentences that they work on, okay? So that's sort of the big picture distinction. All right, now before we move into a truth table though, let's look at the atomic sentences. So don't worry about well, actually I don't think we need the original ordinary language sentence. Don't worry about any of the connectives. For right now, let's build a world, if we can, with the following atomic sentences. D front of C, D front of B, C front of itself. That's not going to be possible, right? D front of B we already have, right? And we're not missing anything?
I think it was, because you repeated D front of
Right,
B,
so what are we missing?
C front of B.
Okay, so C front of B. Don't forget a couple of points here. One is that if you move slowly through things, then you will generally catch an error or an oversight, right? So the error that I made is also an oversight, as Cody points out, missing the CB relation, right? In addition, one of the nice things about Tarski's world and the other programs is often, not always, but often let me rephrase that, often, not always, the programs will tell you if you've made an error,
So
right?
the CB is where the DB should be.
Right. Let's see, what's our original? D front of C, D front of B, C front of itself, C front of B. We okay with that? Okay. So what do you guys think about the world building? Tell me what to build where what we're trying to do is create a world in which each of the atomic sentences is true. How many objects do we need?
4 objects.
We need D. Yeah, let's just go in order. We need C. And by the way, does size and shape matter? No, because the only consideration is the front of relation. So we've got D, we've got C, we've got B. We missing anything else? We've got all three of our objects, okay? We've got D, again, on the atomic sentence level, D front of C, D front of B, and then where's our C and C front of B? Okay, so I'm going to see whether or not this sentence comes out true if I write, so now I'm going to add another line. So front of DC, front of DB, front of CC, front of CB. Okay, so I'm going to verify that, and DCB.
You've got a connector.
Where am I? What did I? Oh yeah, thank you. Forgot the. So by the way, just here's one of those programs catches you out. The asterisk tells me that I do not have a well-formed formula, which is to say it's a logically ungrammatical sentence. So the first thing I do is I'm looking for, parentheses. Am I missing an open or a closed parenthesis? Chris says, hey, you're missing a connective. And I see, oh yeah, you're right, missing a connective, which I've not articulated correctly now. Where's the disjunction? Here it is. We've got a disjunction. Now we can go to verify. We've got a true sentence, right? So far, so good. Now, what's happening? We're in the original sentence, we're rejecting this scenario. What I'm going to do now is hit verify all. Okay. 3, 4, and 5 all come out false, right? So at present, we've got at least one world in which the sentences that Cody was wondering about, and Cody, correct me if I'm wrong, 4 and 5, they have equivalent values right now in this world. Question before us is it the case that we can make a world in which sentence 4 is false and 5 is true, or vice versa? Okay, so what is it that we might try to do? Are there any ideas about this? What do you think, Cody?
You could just make one of the front of CB true and everything else false.
So something like this. Okay. So what we then see is that these two sentences do not say the same thing. Right? How are we doing with that? Basic idea. Right? Let me offer up another world, but before that, how are we doing with the difference? If you read back into the original sentence, right, so neither D nor C is front of either C or B. How does number 5 not say that? Which was an original potential translation. We had our main connective correct. The connective is in front of the parenthetical. And we had the subconnective, the main subconnective correct. It's a not either, but those sub-connectives, the two conjunctions are incorrect. What is it that makes us say those two conjunctions kind of throw a monkey wrench into the translation? That's what we want to think about. Okay. Now, you might say, well, I just see it, I get it, or I don't see it, I don't care, whichever, right? Or I'll keep submitting until Greg Grinder tells me I'm correct. But what I do want to stress though is this: these seemingly subtle differences in logical meaning can have rather significant impacts if we think about the ways in which how we speak or how we believe informs the actions that we take, the decisions that we make, and then undertake certain actions, right? And it's no small thing to be willing to spend the time on the seemingly minuscule parts of our language. All right, let me give you another example. I had mentioned it earlier, but now let's see this play out in the world. Sorry, hold on just one second. All right, come on, world. Sorry. Control new world isn't working. All right, here we go. So if I have the following relation, A is larger than B, right? The smaller relation, B larger than A, is equivalent, yes? In other words, all you need to understand in order to see that these two sentences say the same thing is what the predicate smaller, larger means, right? What the relational predicate, more specifically smaller, larger, means. What we want to understand, though, is that this notion of equivalence is not going to apply in a truth table. And the reason is because these are atomic sentences. And the atomic sentence does not involve a connective, and a truth table is designed to test possible truths and falsities of sentences that are governed by connectives, right? It doesn't mean that if you have a cluster of sentences, one of which doesn't have a connective, you can't use the truth table. We saw that on Thursday. But it does mean that when you're dealing with looking at, for example, equivalences, or you are asking after whether or not a sentence is necessarily true, you're going to use a truth table when you have connectives. What else does the truth table not recognize? Because it focuses exclusively on, or is sensitive to, as the text says, connectives. And I should say, when I say exclusively on connectives, what I really should say is the way that connectives work on either atomic sentences or on already compounded sentences, right? Is that the truth table doesn't take into consideration the meanings of the atomic sentences, okay? So here, if I have two objects, right, I'm going to make one A and the other B, I ask myself, and this is another nice reason to have a world where you can try to actually see what it is that you're doing from the standpoint of objects. Can I make a world in which sentence 1 is true and sentence 2 is false? Can I make a world in which sentence 1 is false and sentence 2 is true at the same time? We all say no, right? And you kind of probably are thinking, well, Mia, it's a no-brainer no. So we've got 2 atomic sentences. Sorry, guys, it's so awkward functioning this way. 2 atomic sentences. A is larger than B. B is smaller than A. 2 atomic sentences in a truth table mean that there are, according to a truth table, how many possible values? 4. Let's just let Boole, for the sake of time, fill these in, right? Now, these are just the referent columns, right? These are the atomic sentence possible values that are then applied in a sentence on the right side, right? But we don't have any connectives. So we don't even need to take the time to rebuild those sentences in the sentence window. Look at row number 1, look at row number 4, and you can see, yeah, these 2 sentences have the same value, right? But look at rows 2 and 3. On rows 2 and 3, these 2 sentences have contradictory values, right? This tells you that the truth table does not detect any kind of nuance in language in terms of semantics. Does this make some sense? So I'm trying to sort of hammer away at the point that the truth table is able to deal exclusively with how connectives operate on sentences in order to generate truth values, right? So a sentence in a truth table is true or false as a function of the connective operating on the atomic sentence. Go on, B. Hold on. B, you were so close. Yes, bye. Go on. Bye. Isn't that sweet? B just said, okay, sure, I'll leave. Okay. So far, so good. Yeah? All right. How about, let me try one more sentence. I'm just going to take the following. We've already got B, so A is identical to C. C is identical to A. And we need to name C. Right? So now cast your eyeballs over sentences 3 and 4. You're comfortable because you understand what the identity symbol means with the idea that A is identical to C says the same thing as C is identical to A. Right? So far, so good. What do you think is going to happen in a truth table? Same thing as the sentence we have in here now. Let's go ahead and just delete. Why are you not deleting? For some reason, there we go. My shortcut command wasn't working. All right, so let's go ahead and construct these 2 sentences. Sorry, the mouse does, because of the way that this is sitting on the cart, the mouse doesn't want to move the way we would expect. Okay, right? So same thing. The truth table does not detect what the identity symbol means. Moreover, the identity symbol is not a connective, it's not an operator, right? So that the truth of an identity sentence is not the function of the identity working as a connective on sentences, okay? So we've got sentences that are logically equivalent, but that doesn't mean that they are truth functionally equivalent or truth table equivalent, right? So you don't want to say that just because you have a logically equivalent set of sentences that that is also going to bear out in the truth table. What about the other direction though? What are you thinking?
You were saying this logic equivalent is by not functionally equivalent?
Truth functionally equivalent or truth table equivalent. Right? So part of what we're getting in it at this point is a distinction, just like we got a bit of a distinction with respect to atomic sentences between how we talk about truth in terms of a world that you can build versus truth in terms of a table that you can build, right? World as in this case, Tarski's world, table as in possible scenarios, that is truth conditions. So let's revisit a sentence that we had already. And then we will move on. Okay. So the following, I'm caps locking it. The following should look familiar now. I don't mind repeating examples if for no other reason than oftentimes the more we see the example, right, at the very least, the more familiar we are with it. So you guys remember this one, right? A, B are our atomic sentence, atomic sentences. And then we have, oh, this is so annoying, sorry. And then we have negation, parenthesis, A, disjunction B, close parenthesis, new sentence, negation A, conjunction. Oh, goodness sake. Sorry. This is so annoying. Negation B. Okay, here we are.
Disjunctions?
We have a disjunction within the parenthetical. And then in sentence 2, we have a conjunction as the main connective and the negation on each side, right? So this should look familiar, right? Does everybody remember this from last week? Okay. So the question that we ask about truth values on a truth table or in a truth table with respect to equivalences, under what conditions, right, is each sentence true? Under what conditions is each sentence false? Such that we end up with the same values on every row of the truth table in the column under the main connective, right? So we remember that for the first sentence, we have as our subconnective the disjunction. Remember, your main connective is never the connective within a parenthetical. So that just leaves in this case, the negation. So first we determine the values of the disjunction. We do that when we have the cursor in the column under the disjunction by way of the reference values, right, that are highlighted. So Boole highlights those for us. And we know that a disjunction is false when and only when each of the disjuncts is false, true, 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 false. now we're in a position, as you can see, the bool program tells us, we're in a position once we click in the column under the negation to act on, or have the negation act on, I should say, the disjunction. What are you thinking, Kelsey?
So we're supposed to make 4 rows, I'm assuming, to get like the truth value.
Right, and one of the things that we want to talk about today, we only mentioned it briefly last week and we didn't really, practice with it, is how you know how many rows of a truth table to build for a sentence of a certain complexity.
But it could go more than like 4 rows, or is it just like a limit that you have to like finish?
The number of rows is determined by the number of atomic sentences. So there will be a limit set by that number. Yeah, great question. So we know that the negation's value is always the opposite of the sentence it's negating. So we get false, 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 true. Now we're in a position to move over to the other sentence number 2. Again, I hope that it feels to you like we're beating a dead horse conceptually here. That's a good thing, not for the horse, but, well, the horse is dead, so there it is. But for you, because it means you're, I got it, Mia. That's a good thing. So we know that we're going to work our negations first, right? We know what the reference columns are that we're considering, or in this case, sorry, the referent column. So we've got what? False. False. Not true is, or sorry, not false is, sorry, Michaela, I messed you up. Not false is, yeah. Do we see that? Have I confused us?
So you just switch it.
Yeah, you just switch it.
That's what you did for the first one too.
Uh-huh.
With
Yeah, so first, so let's go back. So first we determined our disjunctions values, right?
the disjunction, determine the value.
So these two values,
Are true, so then that one has to be true.
yes, these two values are being acted upon, if you will, by the disjunction. And we know by definition that all you need for a disjunction to be true is for one of the disjuncts to be true. The shorthand that we focused on was falsity. A disjunction is false when and only when each of the disjuncts is false, right? So we did all that, and then now, Rachel, coming to your question, once we determine those values, what is being rejected, what's being negated? It's a not or, it's a neither. So not or, so not true is false, not true is false, not true is false, not false is true. All right? Then we're moved over to, notice you've got the green highlight. So when you click on the column under the negation, bool says, look over here, right? So not true is false, not true is false, not false is true, not false is true. We then move over to the second negation, do the same thing. Yep, false, true, false, true. Now we're in a position when you have your cursor in the column under the main connective, which here is the conjunction, bool highlights each of the negation sentences. And we know that a conjunction is true when and only when each of the conjuncts is true, which means we've got what? False, 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 true. Beautiful. Now, if you are unsure that you've worked your truth table correctly, remember, you can check your work. You can verify a row, you can verify the whole table. We have not only correctly determined the values, we've also, in so doing, we've constructed a complete table. But now let's assess the sentences. So this should look familiar, right? Take a look at these two boxes, I'm gonna, since both, show up, let's look at both, but let's look first at equivalence. Kelsey, what are you thinking?
So we're supposed to create the truth table into sentences,
So you'll get, for any exercise, let me rephrase that. The text will say, hey, here are sentences. Go ahead and build a truth table, and you're going to evaluate either multiple sentences in terms of equivalence or consequence. You may be given just a single sentence. We'll get to that where we're talking about possibility and necessity, where you're evaluating the sentence, where you're evaluating a single sentence. So notice here, this top box, or top pane, I don't know, is shaded out, and that's because this assessment concept set deals with just a single sentence. We got two. Okay, so we want to know whether or not these two sentences say the same thing. Are they truth table equivalent? Are they tautological equivalent? Are they truth functionally equivalent? Those are three ways of saying the same thing. And you're going to say what? Sentences are or are not tautologically equivalent? Are. Yeah. Now let's remember what we're looking at here. You are looking at the values in the column under the main connective for each of the sentences. So you're looking at, under sentence 1, the values under the negation, for sentence 2, the values under the conjunction, and then you go row by row, right? So notice, I know that I have this highlighted, sorry about that, I have that negation highlighted, but what are we looking at? So, are they equivalent? Yes. Are they equivalent? Are they equivalent? Are they equivalent?
Why are you looking at those two? Why wouldn't you be looking at the same negations? Like first negation. Or the second one, why are you looking at those? Is it
Oh,
because-
why are we looking at the
'cause they're
conjunction?
they're the
Yeah,
main-
you got it. Yep. Yeah. Yeah. So you're toggling, right? T's and F's in terms of saying, look, I'm not after them being true or being false. I'm after answering the question, do they have the same values on every row of the truth table in the column under the main connective, if you have multiple connectives? What are you thinking, Kelsey?
because you know how you had like the 4 rows, so each different row is going to be true, false, right? Like a little pattern.
Right, so you're pressing on a question that's related to your number of rows question, where the values are always going to lay out the same way. So we'll come to that. We'll come to that next, since that's and then we can keep doing the evaluation work. One other question for you, sorry, Chris, what are you thinking?
I just noticed something that my table isn't coming out anywhere like yours. I mean, I typed everything right the way you typed it, and then I hit the verify, and it was false. And I guess the A and the B are not interchangeable, right?
So we're going in the order that the sentences appear. And hold on to that, Chris, because that's a great point, and it's related to the way we lay out our truth tables. I've been doing it and sort of making a vague, it's vague because it's just a mention here and there, but now we're going to really hone in on the mechanics of how you build a truth table from a given sentence. But real quick, question for you. If having sentence 1 means that you also have sentence 2 from the standpoint of truth functionality, and vice versa, you can substitute one with the other, correct? When you say one, you're saying the other and vice versa, right?
So it's like the not
Negation?
Yeah,
Uh-huh.
there you go. So it's like something similar to that, right? Am I assuming?
I don't follow.
Because you know how it says it's like vice versa? No, sorry, I'm confused it for the or. Because you know like the or negation, so that's how it's what it's like comparing to.
Yeah, so we're saying that this not or is equivalent to both are not, right? So since we have these same values, we can substitute one sentence for the other, truth functionally. What that means then is that sentence 2 is a consequence of sentence 1 and vice versa, because they're substitutable. What does it mean to say that one sentence is a tautological consequence of another? That's just, it's truth table valid. In other words, there is no row on which sentence 2 is false while sentence 1 is true. Or if you want to ask about 1 being a consequence of 2, there is no row on which 1 is false while 2 is true. Okay? If that doesn't sort of resonate with you right now, when we revisit an exercise we did on Thursday, I want to show you something on the board that I hope will work for you. What are you thinking, Chris?
I guess I'm confused as to the term sentence. I thought A was sentence, B was sentence. Yeah.
A and
you're
B
not
are
actually-
the atomic constituents
Of the sentence.
of the respective sentences, not either, both are not.
Okay, I got it.
Yeah? Okay, so we'd say they're substitutable. One is a consequence of the other and vice versa. We're gonna verify, assess, yay, we get a check mark. Okay, and what we could do also, Cody, going back to your great point about those two sentences we started off with not being equivalent, you can throw those into a truth table. That would bring us, Kelsey, to your great question about the number of rows. Now that would be a fairly large sentence, so I want to start off with something a little bit smaller. Okay, if we have, let's say, 3, it's doing it again. Grr. Okay, if we have 3 atomic sentences, our number of rows increases exponentially. Here is, if I can, that's not too bad, okay. Here is our formula for the number of rows. So the number of rows in a truth table is 2 to the number of atomic sentences. And the shorthand of this formula oftentimes looks like this. L equals 2 superscript n, or R equals 2 superscript n. Right? Now, another nice thing about Boole is this. If you forget, right, or let's say you've got 5 atomic sentences or 6 atomic sentences, you're like, oh, do I really want to build this, fill in the reference columns myself? Well, remember, Boole will do it for you. Now, that said, don't forget that there are exercises in the text where you're told, hey, don't let Boole fill the reference columns for you. You fill them in yourself. And Grade Grinder will know. So I think it's a really good idea for you to take advantage of letting Boole do this as you're learning the formula. But it's not a bad idea to know how to do it yourself. Okay, so first thing is the number of rows in the truth table is determined by the number of atomic sentences. And then just to push on the question that Chris had asked a moment ago, remember the referent columns are columns that give us the atomic sentences that are the constituents of compound sentences, where the compound sentence is a sentence that involves at least one connective. Okay. Now, Kelsey's other question, and this also relates to a question that Chris had asked, is how we lay out the T's and the F's. So first off, think about the standard left to right orientation. Whatever is your first atomic sentence in a compound sentence, that is going to be the one that goes first on the far left, right? So suppose instead of ABC, suppose we had something like, this, D, oh, I didn't mean to do that. Let's just say delete, that's fine. D, and suppose that instead of A, we have, I don't know, F. Right? And fill. Overwrite. So I changed out for A, I put in F, I changed out D for, changed out B for D, C stays the same. Doesn't matter what your atomic sentences are, the order in your truth table follows the order that the sentences appear in the compound sentence for which the truth table is being constructed. So the first sentence on the far left always gets half the number of total rows, T. That was grammatically an odd way of putting it, but the first half of the total number of rows gets values of T, the second half F. Then the second is going to take half of the first set of T's and alternate that with 2 T's and 2 F's. So it'll be, so if you have 4 T's, you'll take half that set and get 2 sets, 1, 2 T's, 2 F's, 1, 2 T's, 2, and all the way down. And then regardless of how many rows you have, your last sentence on the right is always going to alternate true, false, true, false, true, false, true, false. All right, so what if we do this? Let me make a new window, and you guys are going to have to do what you did before, which is correct me when I type the wrong thing. Do you remember the elements of the front of relation? Because I don't. Tell me what to write. Was front of, well, I think I remember DB. Is that right?
That one was,
Yeah.
DC.
DC, okay, and then front of
DE.
DB.
Front of CC.
What a column, what is that? Okay. Sorry, I'm trying to, after. Front of CC.
Front of CB.
Goodness sakes. Front of CB, right?
Yes.
CB. Okay. 4 atomic sentences means 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 rows. Okay. 16 rows, the first sentence of which, and I'm just telling you well, you remember the order, right? But I'm just telling you the order was 1, 2, 3, 4, front of, with the specific constants. So if it's 16, it's going to be half 8, really, Mia? Mihai says it's going to be 8, how many, of what? 1, 2, 3, 4, 5, 6, 7, 8. Schlemiel. 1, 2, 3, 4, 5, 6, 7, 8. Okay.
You date yourself.
I know, I totally did, yeah. But you got it, so you did too, Chris.
I know I did.
Right, so we have 8 true, 8 false. Row number, or sorry, atomic sentence 2 is going to take half of the first 8.
4 true.
4 true, 4 false,
Once.
right? So, true, 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 true. Where is it? False, 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 false. True, 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 true. False, 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 false. What do you think is going to happen at 3. Remember, so sentence 2 took half of the first 8, so that is it. We took 4 and we duplicated the values. The other 4 F's, right? Half again, half again. What are you thinking, Raz, for the third? Now we'll have pairs of 2, right? So true, true, false, false. Uh-oh, thank you. Yeah, so I did.
Column first, 2. So it goes 4 true, 4 false, 4 true, 4 false.
Hold on just a second, because I did something. There it is. Okay. Sorry, Chris, say again.
The second column is 4 true, 4 false, 4 true, 4 false.
Correct.
So it's half of, you take half of the first one, and then half that,
Yes,
and then just repeat it.
yes.
Okay.
And then now with the last one, we do what? So sorry, Kelsey, you have a question though.
We have an extra, I don't know if that's an F at the end on the third row, how come there's another one extra than the first 2 columns? It's just the line.
Oh, my cursor is, yeah, it's just because the cursor's here. There's no value here.
And then the other one is TTFF.
Okay, so the last one always, the last one on the right is always? Yeah, alternate. True, false, true, false, true, false. Ah, I did it again. Yeah? Okay.
I'm sorry.
What are you thinking?
So as you move over, you have the amounts of truth.
Yes, you keep halving, having. Yeah, HALVING. Yeah, yeah.
Okay, so you
Yeah.
just keep on halving it across when you go into the last one, which no matter what, it's going to be alternate true false.
What do we think? It's pretty good? So this is the convention that we use. And just to reiterate, I mean, we're assuming that the sentence that we would write in on the right-hand side begins with the DC front of relation and continues 2, 3, 4. Okay, so those are some of the mechanics of the thing. What do we think? So far, so good? Okay. All right. So so now let's see if given the hiccups and whatever else, we can pull some ideas together, make sure we've covered the following. Working backward, we've talked about setting up the truth table. So what's the order of our atomic sentences? Setting up our truth table. How many rows do we have? Setting up the truth table. How do we begin? Well, it's more about setting up the truth table. How do we make divisions between one sentence and another? Right? We know how to do all that. We also looked at whether or not a sentence follows from another sentence or sentences. In this case, it was 2 sentences that are truth functionally equivalent, right? And there's still an outstanding question for you just to keep thinking about. Is it the case that any truth table equivalent sentences are also going to be logically equivalent if we want to and can build them in Tarski's world or anywhere else for that matter? Okay, what are you thinking, Mihai?
So then a question, if they're logically equivalent, then they also have to be logically possible. Is that a fair assumption? As far as the truth table goes.
So let's ask this question. Can you think of a sentence that's never true?
Sky is green.
Okay. That will be that's an atomic sentence.
Right.
So if we start to operate on it, we'll get different values. How about this? So does everybody have in mind Mihai's great question? He's asking this, and correct me if I've got you wrong. 2 sentences that are equivalent, truth functionally equivalent, tautologically equivalent, truth table equivalent, that those 2 sentences are also each truth table possible. And I said, well, what about a sentence that's always false? So let's try one. Let me do this. Since I think given the constraints of using this cart, it would be easier just to make a new window. Suppose that I have this sentence. Oops, I didn't mean to do that. Forgive me. I have A conjunction not A. Okay, how many atomic sentences do I have?
One.
I have one atomic sentence. So I have how many rows? 2, right? A is true or A is false. Question of the conjunction and the negation, which is the main connective, which governs the sentence? In other words, is this an and sentence or is this a not sentence? It's an and. So that means we're going to generate our negation values first. So what do we think? False and true. Now we go over to the conjunction and we're asked to compare the original atomic sentence with the negated sentence and we get false, false. Okay, so this is a sentence that's known as a logically false or known as a self-contradictory sentence. It is not truth table possible, right? There's no scenario in which the sentence A and not A, whatever A might happen to stand for, if you want to turn it, I have apples, I don't have apples. You can't say that I have this and I don't have that. It can't obtain, right? So Mihai's question is, if I have 2 sentences that are logically equivalent, will they each be truth table possible? Does everybody remember the definition of truth table possible? A truth table possible sentence is a sentence that's true on at least one row of the truth table, right? There's a possible scenario or there are conditions under which a sentence is true once, at least once. But we could say that A and not A, the self-contradictory sentence, is equivalent to truth functionally to a sentence. What do you think that might be?
A or not A.
Is it going to be A or not A, or is it going to be? Let's try this and see. What do you think? Disjunction is the main connective. So once again, we've got to calculate our values first. Yeah, this sentence, A or not A, is known not only as a truth table possible sentence, because it's true on at least one row, it's a truth table necessity, it's a tautology. A tautology is a sentence that is true on every row of the truth table. So these guys wouldn't be equivalent, but what do you think? Now that you've had this one, what do you think? You could do this, right? It's a little wordy there, but still.
What is it?
So number 3 says negation, open paren, A, disjunction, negation, close paren. Right? So here we've got the same values, right? So we've got true, true, which means that the negation is going to be false, false.
So it's equivalent.
Equivalent, yeah, they are truth functionally equivalent, but that doesn't mean that each is truth table possible. Great question. What are you thinking, Rachel?
So, I thought since there's like 3 questions up there,
There are 3 statements. Yep.
Why is there only one on the left-hand side? I thought that it goes according to, because you have A right there.
Yeah.
And you just have TF.
Yeah.
Why don't you have like
More? Well, because all we have in each of the three sentences
A.
is, yeah.
So, I'm just like confused on like when you would put true or false. Like when you did the last example, like I understood it, but in this case, like you put what you are not trying to find first, like what's not in the parentheses. Which one?
So,
Which line do you know to put false or true?
okay, so you're comfortable with the atomic values,
Yeah,
right?
because I know there's only A.
Okay, then for sentence number 1, the negation is the subconnective,
I
so
missed
that gets determined, those values are determined first. Conjunction is the main connective. The conjunction brings together A and not A. So the conjunction is going to operate on the negation values and the atomic A values.
Okay, I get it. So
Yeah.
you just switch it because it's A, but the opposite because it has a negation.
Correct.
So you have true, false. So you would put false, true.
Correct.
So then, why did you put false, false for the third on the right? Why isn't it false, true for that?
So on the third, so let me go ahead and to fulfill all righteousness,
Oh, it
complete the
is.
table,
Okay.
right? So that was the negation value, then we have the disjunction, and then we reject the disjunction.
Can you make these big?
I can't. Unfortunately, Chris, and in fact in the newer version of Boole, at least if my understanding is correct, there's no scalability. So you can make the font bigger, but it doesn't scale, so the columns get all wonky.
So,
I know it's a pain.
So I guess I can't read it very well. A is TF.
A is TF, yep.
Then when you move over to the first sentence, A would be TT or TF? TF.
The first sentence, A is TF, not A is FT,
Okay,
conjunction FF.
FF. And then the other one is TF, second one.
And then number 2, under the negation, FT,
FT, okay.
and then under the disjunction, TT,
And A is TF.
and A is TF, yeah.
Okay, and then the other one, A is TF. Like I said, I can't read it, so. On the third one, A is which?
So on the third one, we have negation, parentheses, A, disjunction, negation, A, close parentheses.
Right.
Mm-hmm. So A is always going to be TF,
A is always TF.
always TF.
So the negation would be outer negation.
The outer negation is the result of first the negation of A, then the disjunction A or not A, then the negation of the disjunction.
Okay, so you already figured that
Yeah.
outer disjunction, yeah.
But you don't put the A, right? You only do like the negations and conjunctions and the disjunctions.
Right, well, so there are a couple of ways you can lay out the truth table. So let's do this. So I don't know, Chris, if this will help. So here's the first sentence, A, conjunction,
Not A.
not A.
I got
Second
that.
sentence,
A can,
A, disjunction, not A.
right.
Third sentence, not parentheses, A, disjunction, not A, close parentheses.
Right.
Now, if you want, you can't do this in Boole, but if you want, let's say on the board, you can take each of your values for the atomic sentence A, and you can put them directly underneath, right?
Right.
So and then you start your work, right? So the main connective, I'm putting an arrow over, right? So negation T will be false, negation false will be T, and then conjunction false, false, right? Then we have the same thing again, negation T, negation F.
Okay, you put values under the negation symbols as well.
You have to do.
Okay, I was confusing myself. I was considering not A as a value. And that was where I was putting them two things.
Well, not A does have a value. It's negation of the A.
Right.
So whatever A is, it's not the case. And then our last one we do false, true. Then we have our disjunction, true, true, and then our negation, false, false. So bool doesn't, the reference column is there so that you end up saving time, right? You're not putting the values, the possible values under A each time you're working through a truth table. Just basically saves you time. Okay, what do we think? What do you think,
I always get
Rachel?
a little confused. I know you repeat it, but like the conjunction, that first one is a conjunction, and
Yeah.
a conjunction is false or true.
A conjunction is true when and only when each of the conjuncts is true.
So they would all have to be true. That's why they're all false.
Yeah, good
And
for
then
you, yep.
The disjunction, as long as one of them is false, or as long as one of them is true, then it's true, right? For the disjunction.
Yeah, as long as one is true, the disjunction
That's why they both are true.
disjunction is true, yeah.
And then for the negation, as long as
It's always the opposite
it's
value.
always, so what is it? The opposite of
Whatever value the negation is operating on.
okay.
All right, so let's do this. I think for the sake of time, we still want to get to the notion in more concentrated terms of logical possibility and see the connection to tautology. But I want to try something that I hope will help in terms of the notion of consequence. So you guys remember, let me erase this for the sake of a visual. Sorry, I didn't ask you if I can erase it, I just went ahead and did it. All right, you guys remember that little girl we made cry? Right? Remember, hey, little girl, I've got candy in my left hand or my right hand. It's not in my left hand. So,
Right.
ha 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 ha, it's not. And the little girl was either really, really angry or started to cry, depending on what temperament she had, right? What was the problem? What did I do? I lied, exactly, Luis. I lied. I said, and the little girl agreed, candy's in one hand or the other. That was what I ended up contradicting, right? Okay, so you guys remember the truth table here. So possible values for P and Q lay out this way, right? Because of the order of the sentences. And remember that Q, as an atomic sentence, does not have any connective working on it, so we just simply copy over its possible values as an atomic sentence, right? And we know what? What do we know about the disjunction? The disjunction is false when and only when each of the disjuncts is false, so we have true, 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 false, yes? And we can scribble these out so they don't distract us. Negation is the opposite of the sentence's value that's being negated, so it's false, false, true, true. There's nothing to do with Q, is there? Okay, so question for you, and I'll do this if it helps. Is there a row on which the premises are true and the conclusion, which I'm signifying just with double slash, is false? Is there a row on which the premises are true while the conclusion is false?
Second row.
Premises are true.
So both
Correct.
Oh,
Is it the case that both premises are true while the conclusion is false? No. Right? What's the row where I lied to the little girl? So Jennifer saying third, I think what you're doing, Jennifer, is you're saying this is what the little girl took to be the case. If my premises are true, my conclusion must be true. But what was the actual case? I lied to her. It's true or false that I have candy in one hand or the other.
False.
Right, and it's false that I have candy in the other hand, right? So what row? Row 4, this is the lying row. Is there a row, though, where the argument fails? No. So we will say that Q is a tautological consequence of the premises. We will say that the argument is valid. Here's a shortcut to show what happens when we try to say that the argument is valid. It also helps with what Luis pointed out earlier as my lie. Okay? Some of you might like this. I'm hoping you're going to like it.
right.
What if I say, you know what, argument, I don't believe you. I don't believe you're valid. I believe you're invalid. An invalid argument is one in which the premises are true while the conclusion is false. Yes? Notice now I'm going to work backward. I've started with my connective for each premise. Now I've got to work backward.
The
Okay.
premises are true.
So assume invalidity, which is true premises and false conclusion, which I'm abbreviating as CONCL. All right, so if Q is false, what do I need to do? Plug it in. But if I'm saying that P or Q is true, what must P be? True. That helps me to preserve my true disjunction. But if I'm saying that P is true, oh no, everybody, look. I've contradicted the truth definitions.
But shouldn't that be false though?
Can't make it false. In other words, what you're saying, Rachel, is when an argument is valid, but I try to say that it's invalid, I run into a contradiction of a truth definition. I could run into that contradiction on the disjunction too. So think about it this way. What if I said, okay, if not P is true, that means P must be false. And if P is false, I plug that in there. If P is false, but the disjunction is true, that means that Q must be true, but oh no, here I go again, contradicting the values. Huh?
Yeah, I get it.
Does anybody like it?
It's confusing.
You will like it, and guess why? This is the truth table version of a rule we're going to learn in chapter 6. Yes. Just say it. Say it, Mia. It's awesome.
It's awesome.
Okay. So we'll pick a little bit. What we're going to pick up with on Thursday is tautological consequence, logical consequence, which is the broader picture, and we'll also look at necessity. Okay.